Okay, we're going to start section 10.3 now. So similar to what we saw with 10.1 and 10.2, like in 10.1, they kind of just talk about, in general what parametric equations were and give you some examples of that and stuff like that. And then in 10.2, we talk more about the calculus part of parametric equations. But the same thing is going to happen here with polar coordinates. So in 10.3, we're going to talk about just, in general what polar coordinates are. And we'll look at the graphs and stuff like that. We'll do some things in the calculator. And then in 10.4, we'll look at the calculus with polar coordinates. Okay? So now so far we've been plotting points in the rectangular coordinate system, okay? Or the Cartesian coordinate system, that's the same thing. In this section, we're going to introduce another coordinate system, which is called the polar coordinate system. Okay? Definition, any point in a plane can be identified by its distance, r, from a fixed point and its angle of inclination, theta. This type of coordinate system is called the polar coordinate system. Okay? Now, the fixed point is called the pole, and that's terminology that you'll see in the book. And the initial ray is called the polar axis. So here's a picture. I get the pole, or the origin, same thing, and then the polar axis, which is the x-axis, same thing. And I'm going to go out some distance on the polar axis to a point, and then swing that point about the pole, okay, using a circular path. And the radius is r, okay? And this angle theta is the angle of inclination. So point P, if I land here, let's say, is going to have coordinates r theta. Now, just like with Cartesian coordinates, order matters. So x has to be written first and y has to be written second. If you switch them, this doesn't mean the same thing, right? Same thing here with polar coordinates. So r theta, we don't write theta comma r, okay? So let's see, in this first example, I'm just giving us some practice plotting some points in polar coordinates. Okay, so let's plot the point 1, 7 pi over 6. Now, by the way, one of the things that we should have an idea of before we plot a point is which coordinate we're going to be located in. Just like with Cartesian coordinates, like if I ask you to plot the point negative 1, 1, you should have an idea about what coordinate that's going to be in, right? You mean in quadrant 2, okay? The same thing here. So now one complete revolution around the pole is of 2 pi radians. So let's see, I got 7 pi over 6. That means I'm going to be in quadrant 3, right? Because 6 pi over 6 would be pi. That'd be right over here. And then I'm using a radius of 1. Okay, so I need to go 1 increment on the polar axis and then swing that point to be located here in quadrant 3. Okay? Now, with polar coordinates, like there's major axes and there's minor axes. Okay, the major axes would be 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, 2 pi radians, etc. Okay, just the 4 major axes. And then the minor axes would be all the other angles that are common, okay? Specifically like increments of 30 degrees and 45 degrees, like those are going to come up all the time, right? And so those would be the minor axes. I got the 30-degree axis, the 45-degree axis, the 60-degree axis. Now, just like for most of the problems here, they're going to use a radian measure. Okay, so there's the pi over 6 axis, the pi over 4 axis, the pi over 3 axis, etc. Okay. Here's another problem. So suppose that we want to plot the point 2, 3 pi. Okay, so I need to start out by going out 2 increments from the pole. So I'm going to be right here. And then I need to swing that point 3 pi radians. So 1 complete revolution around the circle would be 2 pi radians, right? So I need to go another pi radians to that point 2, 3 pi. Okay, by the way, so with the rectangular coordinate system, we only got two axes, right? There's the x-axis and the y-axis. With the polar coordinate system, there's infinitely many axes. I want you to take note of that. So there's infinitely many axes. Like I got the 0 radian axis, there's the pi over 6 radian axis, there's the pi over 4 radian axis, there's the pi over 2 radian axis, there's the 3 pi over 4 radian axis, there's the pi radian axis, right? So I'm going to have all infinitely many of these axes shooting out from the center. Okay? Here's another one. Let's plot the point 2, negative pi over 4. Okay, theta can be positive or negative. It's the same thing with r. Okay? So let's see. R positive means you're going counterclockwise around the center. R negative means you're going clockwise around the center. Okay, so I need to go out 2 increments from the center, and then I need to swing that point clockwise, negative pi over 4 radians. Well, that's going to put me in quadrant 4. By the way, there's lots of different coordinates that you can give in polar coordinates. Okay, 2 negative pi over 4, that'd be the same thing as 2 7 pi over 4, right? Like if I were to go out 2 increments on the polar axis, and then swing that point this way, 7 pi over 4 radians, I'd land in the same spot. Okay, so 2 7 pi over 4, that'd be the same, that put me at the same spot as 2 negative pi over 4. Okay. Here's another example. So what if we had negative 2 pi over 4? Okay, well, yeah, the radius can be a negative number. Okay, so if I go out to, like here's the pi over 4 radial line, right? Now, negative means I'm going in the opposite direction. So I don't want to go two units out on the pi over 4 line. I'll be up here in quadrant 1. I'm going to be going 2 units in the opposite direction. That's going to put me in quadrant 3. Okay, so I'd be at the point negative 2 pi over 4. Now, negative 2 pi over 4, that would put me in the same spot as if I were to go out 2 units and then swing that point to 5 pi over 4 radians, right? I'm going clockwise. Or if I were to go out 2 radians and then swing that point negative 3 pi over 4 radians, I'd be going clockwise there. And it's going to put me in the same spot. So in other words, you know, polar coordinates have many, many different forms that you can give. Okay, just make sure that you're landing in the same in the right spot, obviously, when you plot these points. Now here's the connection between polar coordinates and rectangular coordinates. So when I plot a point in rectangular coordinates, like here's the origin, I'm going to go out some distance x, and then up or down some distance of y, and I plot a point, and I'm calling that point P. Now in radian measure, I'm going out to an increment of r radians, and I'm swinging that point then by an angle of inclination theta. Okay, so like here, here be r, let's say, and I'd swing that point up to there. Now that's going to put me in the same spot as the point xy, but I'm using polar coordinate form. So r theta would be the same thing as xy, but that does not mean r is equal to x and theta is equal to y. Don't get those mixed up, okay? Well, now we're going to have to know our conversion formulas. Okay, so how to go from polar form to rectangular form, and then rectangular form to polar form. So let's see, in this triangle, and this is a right triangle, by the way, that I've made, cosine theta, that's adjacent over hypotenuse, that'd be x over r. And sine theta is opposite over hypotenuse, that'd be y over r. Okay, well, x over r equal cosine theta means that x equals r cosine theta. And then sine theta equals y over r means that y is equal to r sine theta. Now that should look very familiar. Like we did that, in the last problem here, up here. Okay, now I mentioned that in this section, 10.2, but I mentioned that these equations here, these can be very, very important. Very important. Okay, so these are the equations that we'd have for polar form. Okay, so if you were to go from polar form to rectangular form, these would be the formulas that you'd need. Okay, because you're going to know r and theta, you just got to find x and y. Now, you're also going to have to know how to go from rectangular form to polar form. So if I have coordinates x, y, I need to know how to get into the form r theta. Okay, well, r squared is equal to x squared plus y squared. That'd be a circle of radius 1. Okay, and I can use that formula because I'm going to know x and y. I can get r. And then tan theta is opposite over adjacent. That'd be y over x. Okay, I know y and x, so then if I take tangent inverse of both sides, I can get theta. Okay, so let's get some practice converting points here. Okay, convert these points to rectangular coordinates. So right now they're in polar coordinate form. Okay. Here's one example, 4 pi over 6. Okay, ask which quadrant we should end up in. Well, so I'm going out 4 increments, and then I'm swinging that point up pi over 6 radians. So that's going to put me in quadrant 1, right? So in rectangular coordinates, if I don't get a point in quadrant 1, I got a wrong answer. Okay, I can know that right away. I'm going to land in quadrant 1, right? So r is 4 and theta is pi over 6. Well, using these formulas here, x equal r cosine theta, that means that x is equal to 4 times cosine pi over 6. Cosine pi over 6 is root 3 over 2, and so when I multiply that by 4, I get 2 root 3 as the x value. Y equals r sine theta. R is 4, theta is pi over 6. Sine pi over 6 is 1/2. Okay, and so 4 times 1/2, that's 2. Okay, so my answer then, well, where this point would land in if I were in rectangular coordinates, would be 2 root 3, 2. Yeah, and both those are positive numbers, right? So that makes sense, because, I'm going to go to the right 2 root 3 2 root 3 increments, and then up 2 increments. Okay. Here's another problem. So I got -4, negative pi over 4, and I'm in polar coordinate form. Okay, so r is -4, theta is negative pi over 4. R and theta can be positive or negative, doesn't matter, right? I'm going to use these same formulas from before to get x and y. So x is equal to -4 times cosine of negative pi over 4. Well, the cosine function, that's an even function, right? So cosine of negative pi over 4, that's the same thing as cosine pi over 4, which is 1 over root 2. So I'd have -4 divided by root 2. If I rationalize the denominator, which wouldn't be a necessary thing, but if I did that, multiply the top and bottom by root 2, I get -4 root 2 divided by 2. That'd be -2 root 2. And but by the way, so one of the things that I'd want to know here is which quadrant should I end up in? Well, if r is a negative and theta is a negative, let's see. Theta negative means I'm going clockwise around the center, so I'm going to go negative pi over 4 radians. I'll be down here in quadrant 4. And then r negative is going to put me into quadrant 2. So if I don't get a point in quadrant 2, I've got a wrong answer. Well, to be in quadrant 2, I have to go to the left of the center. That looks good. I got -2 root 2. And then to get the y value, r sine theta, I got -4 sine negative pi over 4. Okay, sine of negative pi over 4. If I have a triangle there in quadrant 4, the opposite side is -1. The hypotenuse is root 2. So -4 times -1 over root 2, that'd be 4 over root 2. And if I rationalize the denominator there, multiply the top and bottom by root 2, I get 4 root 2 over 2, or 2 root 2. Okay, so this would be the answer then if I were in rectangular coordinate form. Okay, so I go the left 2 root 2 increments, and then up 2 root 2 increments. So that's going to put me in the quadrant 2, okay, which is the same quadrant as -4, -pi over 4. Okay. We'll look at the next page then in the next video. So we also need to know how to go from rectangular form to polar form. Okay. Basically, these formulas are very, very important. We need to know those. Okay, we'll be using those a lot, actually. Okay, but I will go ahead and stop the video here, and we'll pick up with that in the next one there.